We're going to start today with what is electricity. Electricity is the flow of electrons. If the electrons aren't flowing, there is no electricity. If they are flowing, then it is electricity. It is similar to the flow of water, not in all respects, but it is similar to the flow of water. Electricity has pressure, and it has volume. Now, the pressure that an electrical charge has is measured in volts. That is a measure of potential difference, which is it's sometimes called. Okay. It is measured kind of like water, in that it's the difference between 2 points, kind of like air pressure. When you gauge up, when you do the pressure on your tire, you'll see, say, 30 pounds per square inch. Well, that is called the gauge pressure. That is the difference between the pressure inside the wall of the tire and outside the wall of the tire. It's a difference between 2 points. Electricity is the same way. It is the difference between the potential difference between the positive and the negative terminals of a battery, or the positive and negative wires from a power supply. So, but it is the electrical potential difference between 2 points, and it's measured in volts. Volume is measured in amps, or amperes. Amps for short. But that's the volume, the number of electrons going through the current, going through past a particular point in a circuit. So you'll see different values for different things. Sometimes you'll see a high voltage, like fluorescent lights. Are these fluorescent? Some of them are, I think. Fluorescent lights use a high voltage, a high pressure, high voltage circuit within the light bulb, but it's very low amperage. So the overall power is fairly low. A electric train, for example, has high voltage and high amperage, which would be more power. Power enough to push a train. Like the electric, I believe the subways in New York and the L in Chicago are, I believe, electric. So, so as you might imagine, power is equal to volts times amps. And this is measured in watts. and volts and amps. So a high power circuit will have a high voltage and a high amperage. Example with, to use a water example, a garden hose has fairly low pressure and medium volume. Switch things around a little bit. A water pick, water toothpick type of thing you have in the bathroom has high pressure and very low volume. So the power isn't going to take your gums off of your jaw, kind of a thing. Whereas a fire hose has high volume and high pressure. That'll take your skin off if it's up to its maximum pressure. It will knock you on your butt and possibly take some skin off. Likewise, in electrical circuits, you'll have high voltage and low amperage. Some will have high amperage and low voltage. So, and various points in between. Let's see here. Now, there are basically two types of the flow of electrons. You have direct current. This is like a battery. Or a USB port. Those have direct current where the pressure, the voltage is constant between the two poles of the device. The alternate to that is alternating current. Where this is a solid line relative to ground. So this will be, say, for a USB port, it will be 5 volts and 0 volts. Alternating current goes up and down. It alternates between the current flow alternates between going one direction and the other. So for a wall socket, for example, the I believe it's RMS voltage, which is measured about there, is 110 volts, and relative to 0 and minus 110 volts. It'll alternate between the two. Another example of a alternating current would be the alternator in your car. Generators in power plants generate alternating current. So the alternating current fluctuates, at a certain frequency, at a particular frequency between high and low. Just for the typical wall socket, that would be 1/60th of a second to go through one cycle. or 60 hertz, it would be the frequency. Like the power source, having the direct current versus alternating current, there are two different types of electrical signals. The first would be the analog signal. This is kind of similar to the alternating current of your power supply. It is a signal that varies over time. The voltage might vary over time, like in a like the sound from a microphone, as a signal from a microphone. The sound is an analog signal. So you have microphones. The signal is going to speakers. And various sensors that you'll learn about later in the curriculum. Will generate an analog output where the signal varies over time. Now, a digital signal is, say this is ground, it's going to be one or the other, high or low. So it is, how do I have it written down here? Digital signal is either high or low, not on or off. Off is a different state. USB communication is digital. HDMI. Most of the signals within a computer are going to be digital signals, either high or low. That high value can vary depending on the system, but a common one is 3.3 volts. But it might be 12 for RS-232 communication. It might be 5 for TTL logic. It just depends on the system that you're dealing with at a given time. Like I said, the digital signal is either high or low, not on or off, because if you think about it, when you look at a battery, you got plus, you have minus. So you have plus would be high, minus would be low. Anybody guess what the third state is? No connection at all. Also called the high impedance state. There is no connection to either high or low. And when you have a situation like that, depending on the circumstances, you can get rather unpredictable results from your circuit if you don't have things tied off properly. But that's the basics of, oh, well, wait a minute. I didn't get into, did I skip something? Or did I cover that later? Let's see here. Apparently, I don't have it in my notes, but I'll go over it anyway. There's another simple equation to remember when it comes to electricity. That's Ohm's law. Ohm's law, it shows the relationship between voltage, current, and resistance. So voltage equals current times resistance. So E, the electrical motive force, is that what it says? The E stands for? And I is for induced current, and R is for resistance. Very simple equation. You can determine what kind of current is being used by, algebraically manipulating it to be E over R equals I. If you want to determine how much resistance you need to induce a certain level of current, you can do E over I equals R. One way to remember the equation that I've seen, think of a circle. And if you want to solve for 1, you cover that letter up. So if you want to solve for voltage, it's E times R, or I times R. If you want to solve for I, it's E over R. Solve for R, it's E over I. So that's an easy way to look at it and remember the relationship between voltage, current, and resistance. Well, anyway, that's the basics of electricity and some of its characteristics. Yeah, I'm sure you'll go into it much deeper in electronics class and circuit theory and that sort of those sort of classes. But these are the P equals EI or IE. Power equals current times voltage. And the E equals IR for Ohm's law. Those are two basic equations that you should have memorized by the time you leave Jackson State, because they are fundamental equations that pop up in all kinds of places. So anyway, that's about it for the intro to electricity. Next time we will be getting into a very brief lecture on metric prefixes. That will be Next Monday, not Wednesday. Wednesday there will be no class. The college needs this room for something else at this time, so we are not going to have class this Wednesday. So I will see you again next Monday. Have a good day.